detecting radioactivity. So we can't see radiation, can't feel it, but we can detect it by studying the interactions of the radiation with atoms or molecules. So this is an example of a thermoluminescent dosimeter. And so this measures radiation over a period of time. So dosimeter, it measures the dose. And so if you're working with radiation, you may wear one of these to keep track of how much radiation you've been exposed to. Make sure that it's not too much. So a badge like this can have crystals of calcium fluoride. Calcium fluoride gets excited by ionizing radiation. And the excited electrons get trapped by impurities that are put into the crystal on purpose. And then when this crystal is heated, it will emit light proportional to the radiation exposure. So you wear this badge for a week, a month, whatever the protocol is, and then it's analyzed by heating it and measuring how much light it gives off. So this can be used to monitor exposure of people working with or near radioactive substances. A Geiger-Müller counter is probably what you think of when you think of detecting radioactivity. This shows up in cartoons and all over the place. It's that thing they're holding and it goes click, 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 right? So this measures radioactivity in real time. So you can see, well, is this thing radioactive? Is that thing radioactive? The dosimeter badge is not useful for that. So let's look at how this works. So we have a chamber here that's filled with argon atoms. And as particles pass through here, so here we have the path of a particle, so that would be coming in here. Particle comes in here. As it passes through, it can create a trail of ionized argon atoms. So like an alpha particle, a beta particle. As it goes through the argon atoms, it's going to ionize some of those atoms. We've got a high applied voltage between the anode here in the middle and the cathode. And then we'll get an electrical signal when those argon atoms get ionized, because those ions allow the charge to flow between the cathode and the anode, whereas when they're not ionized, that can't happen. So the original ones just gave an audible click when this happened, and then they had ones with an analog meter here that would show how much was being emitted. And now, of course, most of them have digital displays. This reminds me a little of the Scantron machines, the inexpensive ones. You run the Scantrons through, and it's printing the correct answer next to all the mistakes. And so it makes a noise for every mistake. And so you can kind of get an idea of how the class is doing overall as you run the Scantrons through. It's like if there's a lot of noise, it's like, oh man, that didn't go very well. If it's really quiet, you're like, oh yeah, they did great. So that always reminds me of a Geiger counter. Any questions? Another way to measure radioactivity in real time is a scintillation counter. And here we have those radioactive emissions are passing through a material. It's often sodium iodide or cesium iodide that will emit UV or visible light in response to being excited by these energetic particles. And then that light can be detected and turned into an electrical signal that can be read on a meter. So that's a different way of detecting radiation.